Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Now I am going to discuss chemical properties of S block elements. Last class I have discussed physical properties and introduction and physical properties of S block elements. Now I am going to discuss chemical properties of S block elements. The alkali metals are highly reactive due to their large size and low ionization enthalpy. The reactivity of these metals increases down the group. First properties that I am going to discuss reactivity towards air. The alkali metals tarnish in dry air due to formation of their oxides, which in turn react with moisture to form hydroxides. They burn vigorously in oxygen, forming oxides. Lithium forms monoxide. Sodium forms peroxide. The other metals form superoxide. The superoxide means O2 1 minus. The superoxide O2 1 minus, that is ion, is stable only in the presence of large cations such as potassium, rubidium, cesium, means K, Rb and Cs. Lithium plus oxygen. Lithium plus oxygen, it gives a lithium oxide. 4Li plus O2, it gives a 2Li2O, that is the oxide, lithium oxide. 4Li plus O2, it gives a 2Li2O, that is the oxide. 2Na plus O2, it gives Na2O2, that is the peroxide. 2Na plus O2, it gives Na2O2, peroxide, means O between O single bond, and both oxygen have 1 sodium. Okay, that is a peroxide. And in general we can tell M plus O2, MO2, that is the superoxide. In general, M means metal. M plus O2, MO2, that is superoxide, where M is equal to potassium, rubidium, cesium. In all these oxides, the oxidation state of the alkali metal is +1. Lithium shows exceptional behavior in reacting directly with nitrogen in air to form nitride. Lithium shows exceptional behavior in reacting directly with nitrogen of air to form the nitride. Means lithium reacts with nitrogen of the air and forms Li3N. This is an exception. Question is asked. Okay. Because of their high reactivity towards air and water, they are normally kept in kerosene oil. Generally, group 1 elements, particularly sodium, potassium, because of their high reactivity towards air and water, they are normally kept in kerosene oil. Okay. Now one question may be asked, what is the oxidation state of potassium in KO2? In KO2, what is the oxidation state? Actually, this is the superoxide. Then what is the oxidation state of K in KO2? The superoxide species is represented as O2 1 minus in the form of ion. Since the compound is a neutral, KO2 is a neutral. Therefore, the oxidation state of potassium is a plus half. Okay. Oxidation state of potassium is plus half. Okay. This type of question is asked. Now, I am going to discuss reactivity towards water. Second property, reactivity towards water. The alkali metals react with water to form hydroxide and hydrogen gas. 2M plus 2H2O, it will form 2M plus 2OH minus plus H2. Here M is equal to an alkali metal. Again I am telling you, 2M plus 2H2O, it will give 2 metal ion, 2M plus 2OH minus plus H2. It will release hydrogen gas. It may be noted that although lithium has most negative electrode potential, lithium has most negative electrode potential, okay, its reaction with water is less vigorous than that of sodium, which has the least negative electrode potential, E0, capital E0. Lithium has most negative electrode potential, means it should be very, very reactive according to the electrode potential. Lithium has most negative E0 value. Okay, its reaction with water is less vigorous than that of sodium, which has the least negative electrode potential. Okay. Among the alkali metal, this I am talking about, that lithium has most negative electrode potential, E0. Its reaction with water is less vigorous, very less vigorous than that of sodium, which has the least negative E, very less negative. Okay, very less negative electrode potential. This is among whole alkali metals. This behavior of lithium is attributed to its small size. Why it is like that? Why reaction is less vigorous than that of sodium? Then its answer I am telling you. This behavior of lithium is attributed to its small size and very high hydration energy. Very high energy hydration. Okay, the two reasons are there. First, a small size, and second, very high hydration energy. Hydration energy means when H2O will come to the lithium, then it will release energy. That is called hydration energy. Then it is very high. Okay, that's why it is less vigorous less vigorous than that of sodium. Sodium is more. They also react with proton. They also react with proton donors such as alcohol, gaseous ammonia, and alkynes. These metals, alkali metals, they also react with proton donor which can donate the proton, such as alcohol. See, alcohol OH group is there. Gaseous ammonia, hydrogen is there, and alkyne. In alkynes, hydrogen is there. Okay. Then all these will have hydrogen. Okay. Then they will react with proton donors. Okay. Such as alcohol, gaseous ammonia, and alkyne. Now, next reaction, that is the reaction towards dihydrogen, means hydrogen gas. The alkali metal react with hydrogen gas at about 673 K, means 273 you do minus, then 400 degrees centigrade, or 673 K you can tell. And lithium will react at 1073 K, means around 800 degrees centigrade, to form hydride. The alkali metal, when it reacts with hydrogen gas at about 673 K Kelvin, 673, then it forms hydrides. And lithium is differently. When it will react with 1073 K, means 800 degrees centigrade, then it forms hydrides. All the alkali metal hydrides are ionic solids. All the alkali metal hydrides are ionic solids with high melting points. Means 2m plus H2, M means metal, 2m plus H2, it will form metal hydride, means 2m plus H minus, metal hydride H minus. Okay. Now, next reaction, reactivity towards halogens. The alkali metals readily react vigorously with halogens to form ionic halides, that is the MX, M plus X minus. However, lithium halides are somewhat covalent. Okay. It is because of the high polarization capability of lithium ion. The distortion of electron cloud of the anion by the cation is called polarization. What is actually polarization? I am telling you, polarization. Polarization means the distortion of electron cloud of the anion. Anion will have electron cloud. Okay. The distortion of electron cloud of the anion by the cation is called polarization, because it will develop a positive and negative charge. Okay. Then that's why the alkali metals readily react vigorously with halogens to form ionic halides, means M plus X minus. X means chloride ions, halogens. Okay. However, lithium halides are somewhat covalent. It is because of the high polarization capability of lithium ion. Okay. The lithium ion is very small in size and has a high tendency to distort electron cloud around the negative halide ion. Since anion with a large size can be easily distorted among halides, lithium iodide is the most covalent in nature. This question is asked. The lithium ion is very small in size and has a high tendency to distort electron cloud around the negative halide ion. Since an ion with large size can be easily distorted among halides, lithium iodide is the most covalent in nature. Next property I am telling, that is the reducing nature. Reducing nature. All properties are asked in examination, hence be careful. Now I am going to discuss reducing nature. The alkali metals are a strong reducing agents, lithium being the most and sodium the least powerful. Lithium being the most you can say reducing agent, lithium, and sodium the least, very less, least powerful. Most powerful is lithium and least powerful is sodium in alkali metals. The standard electrode potential, which measures the reducing power, standard electrode potential measures the reducing potential E0. Okay, always you keep in mind the standard electrode potential E0, capital E, subscript 0, which measures the reducing power, represents the overall change. Metal to metal solid to metal gas. This is called sublimation energy. Metal solid to metal gas, it requires energy. Then this is called sublimation enthalpy or energy. And metal gas, it will give to metal ion in gaseous state. Metal in gaseous state, it will give a electron, means it will convert to metal ion in gaseous state plus electron. Now you see, this is called ionization enthalpy. Okay, reaction energy involved in removing the electron, that is the ionization enthalpy. And metal ion plus H2O, it forms metal ion aqueous, metal ion aqueous. Then now this is the called hydration enthalpy. Energy required to convert metal ion like lithium ion plus H2O, then it will form aqueous metal ion, means water will be absorbed with metal ion. Then in this process heat is required. That heat is called hydration enthalpy. With the small size of its ion, lithium has the highest hydration enthalpy, which accounts for its high negative value. E value, electrode potential value will be, you can say, high negative value. Lithium has highest, you can tell, highest electron, this high negative electrode potential, reduction potential. reduction potential, negative reduction potential is highest in case of lithium because of highest hydration enthalpy, which accounts for its high negative E0 value and its high reducing power. High reducing power. Reducing power means it will give the electron. It will give the electron. Means high tendency to lose the electron. Now question is asked that this question generally in medical, this question is asked even in for IIT Advanced also. The E0 for Cl2 oblique chloride ion is plus 1.36. For iodine to iodide ion is plus 0.53. For silver, Ag plus 2Ag, Ag plus oblique Ag is plus 0.79. Next is Na plus oblique Na is minus 2.71. And for lithium plus oblique lithium is minus 3.04. Arrange the following ionic species in decreasing order of reducing strength. They have given iodide minus, silver, chloride ion, lithium ion, sodium ion. These five they have given. It is given in question. You have to arrange these five: iodide ion, silver, chloride ion, lithium, sodium in the order of reducing strength. Here I want to tell you how will you answer this question. This is a very, very important question. How will you solve? Then here I think 1-2 times already told you, again I am repeating you. Actually that there is a way to write this reduction potential according to IUPAC. According to IUPAC, International Union for Pure and Applied Chemistry, which almost all countries of the world follow except few countries. Then according to the IUPAC, reduction is considered as a standard. Reduction is considered as a standard, not the oxidation. Actually, oxidation and reductions both are equal and opposite. Despite that, reduction has been considered as a standard. Then, if you will see this reduction potential chart, if you will see, then it will be arranged according to the reduction potential, negative to positive via zero. Most negative is written in the top, and slowly negative value will decrease, and after that it will increase. It will increase via zero, means negative value will decrease, it will come to zero, again it will slowly it will begin to increase. Then this actually how you will write, how you will arrange all the things, then reduction reaction is considered. According to the reduction reaction, it is arranged. Means first cation you have to write. cation takes the electron. In general, I am talking about metal ion means M n plus you can write. M, capital M, small n plus. We don't know what is the value of n. Then M n plus n electron. We don't know how many electrons are there, n electron. Then M, capital M, n plus. And power, M power you write n plus Ne. It will give metal ion, capital metal. And this metal is now stable. Metals are now stable. Generally metal will be stable in comparison to the ions. Okay, that's why it is considered as a standard, because it is converting into metal. Then it is the way to write metal ion oblique metal. Means cation is converting to metal. That's why it is written like that, metal ion, M, capital M, power n plus, small n plus, oblique M. Means metal ion converted to metal after taking the electron. This process is called reduction. Okay, metal ion will take the electron and it convert to the metal. The process is reduction. Okay, that's why you will see this in a table chart where they have written the value E0 value, a standard reduction value. Then you will find that it is written from negative to positive via 0. Hydrogen has been considered as you can say has been given arbitrarily 0 value. Okay. Then here H plus oblique H2 we should write, 2H plus oblique H2. Its E0 value is equal to 0. And lithium value is least value. Okay, its value is around -4. Okay, -4.03. Then they have given some value in this question. They have given some values, reduction potential values they have given. Okay, now you have to arrange these, you can say, these ionic species. They have given ionic species. You have to arrange according to the reducing strength. Then again, one by one I will tell you. First they have given, actually 5 ions they have given. 5. Okay. First they have given iodide ion. After that silver is there. Silver ion is there. Chloride ion is there. And lithium ion is there. And sodium ion is there. Okay. Then you have to arrange according to the decreasing order of reducing strength. Then now I will tell you values. Why you can say whatever you will write, this sequence you will write, then why I will tell you. Then here E standard, they have given first question Cl2 chlorine. It is converting to chloride ion. Cl2 is, you know that it is a neutral. Cl2 oxidation state is 0. Now it is converting into chloride ion. Cl2 oblique Cl minus, means this is a reduction. Okay. Then Cl minus, 1 minus. First they have given this. And its value is given plus 1.36. See, here in the beginning only I want to tell you most negative means more reducing power, most reducing power. If E0 value, reduction potential value is a most negative, high value of negative, it means reducing power is highest, and whose value is most positive means least you can say reduction value, least reduction value, and reactivity also will be less. Whose value is more negative, most negative, then that element will be more reactive also, plus reducing power will be highest. This is the base on which you will answer these questions, only on this basis. Okay, then now automatically now you will understand. Then this chlorine is converting into chloride ion, means Cl2 oblique Cl minus. Its value is 1 plus 1.36. It is plus, not minus, plus. Then obviously its value, it will be reduction value will be very less because it is positive. Now second, you have to compare. Second, iodine is converting to iodide ion, I2 oblique I minus, means iodine after taking electron it is converting to I minus, and its value is given plus 0.53 plus. But here chloride, this chloride ion means Cl2 oblique chloride ion, in this process value was 1.36 plus 1.36, means more positive than this iodine oblique iodide ion. Okay. Well, and silver Ag plus converted to Ag, means Ag plus it will take electron and convert it to metal, silver metal. Then its value is plus 0.79. Then three values now I told you, plus 1.36 plus 0.53 plus 0.79. Okay, then out of these three you will give least value, least reducing power to 1.36, which chlorine oblique chloride ion. Okay, among these three, chlorine oblique chloride ion has least reducing power among three, and this silver is 0.79, and in the middle is 0.53. Now come to the sodium. Na plus is converting to Na. Okay, Na plus oblique Na. Its value is minus 2.71. Now you can see value minus 2.71. Then it means this is very reactive. Its value is, first it is value, E0 value is minus 2.71. Reducing power is more in comparison to, in total 4, this sodium should come first. Okay, but now again one more value they have given, lithium plus it is converting to lithium, Li plus oblique Li, its value is minus 3.04. Then now its value is least among all, hence the lithium is a most powerful reducing agent, hence lithium will come first. Means lithium is greater than sodium. Okay, and third Third, that is the iodide ion. Iodide ion will be greater than silver. Iodide ion will be because a 0.53 only. Then after the sodium, iodide ion will come. That is the iodide ion is now greater than silver. Because silver now value is how much? Silver value is plus 0.79. Okay, and after that, in the end, it will come 1.36. That is the chloride ion. What you are writing in the last, that you can write here. Means metal is written for the indication purpose, representation purpose. Metal is written. That's why you are writing here lithium. Lithium is a metal. After the reduction, it is converting to lithium. That's why lithium, you are writing lithium is greater, means most reducing power, has a more reducing power than sodium. Both are negative. Lithium is minus 3.04, sodium is minus 271. Hence second position is for sodium, and third position is the 0.53, that is the for iodide ion, and fourth position is that is the silver value is plus 0.79, and the last is the, you can say, silver is again greater than chloride ion, because chloride ion in positive it is 1.36. Then here I have given example. Then in examination, same type of question they will ask. Same type of question. Okay, maybe give other reaction, but you can solve it by the following this method only. Negative to positive via zero. Negative means most reactive and most powerful reducing agent. Means it can give electron, more electron it will give. It has more tendency to lose the electron in the solution when its rod is dipped in the solution, having same ion, same means having the same cation, Zn to Zn, support like that way. Okay, this is the main things I told you, negative to positive via zero. Now I am next reaction I am telling you, that is the solutions in liquid ammonia. Okay, this is again very important question. Many times I have observed they have asked a question. Solutions in liquid ammonia. The alkali metals dissolves in liquid ammonia. Alkali metals dissolves in liquid ammonia, giving a deep blue solution. Which are conducting in nature. That solution is a deep blue solution which are conducting in nature, means current can be passed through it, conducting solution. Okay. Then here in a general way, one reaction you can write in general way. Metal M means metal, alkali metal M, plus this metal, if you will add in the ammonia solution NH3, then here you can write how many moles of ammonia. Here you write X plus Y, small x plus Y. Before NH3 you write in bracket. Then M plus X plus Y NH3. Okay, in bracket write X plus Y NH3, just like a coefficient. Then it will give a product. You should be careful in writing the product. You should be careful. Its product is it will form a complex ion. It will form a metal complex ion, means MnH3 whole 4. Metal tetraamide it will form. Okay, MnH3 whole 4. This is the complex ion. Complex ion. But here, actually, this you can write X plus Y you have written. And this NH3 is bifurcating in two parts. Two products of ammonia you are getting. That's why you have written X plus Y. A small x plus a small y, because ammonia you will get two products of ammonia. It is giving two complex ion of ammonia. Then one complex ion is MnH3. MnH3, how many NH3? Then x, a small x. You don't know 3 or 4 or 5, maybe variable. Okay. Then here x you consider x. X plus y you written that x, maybe 3, maybe 4. Then MnH3 whole x, that you write in a big bracket because it is a coordination compound, complex ion. Then MnH3 whole x in a big bracket write outside plus, it is a cation. It is forming cation. Okay. Then x you have used a small x. Now y, role of a small y is coming. Then other product of ammonia is that electron E, a small e electron, EnH3 whole y. EnH3 whole y in bracket, this you write in big bracket, and outside is negative, means it is anion, means it is giving cation plus anion complex. Two complex it is giving. One complex is of ammonia, MnH3 whole x, and outside it is a plus, means it is the cation. You write in big bracket and outside write plus. That is the cation, and it is giving anion also. That EnH3 whole y, write in big bracket and outside negative. This is the complex anion, means complex cation and complex anion both are forming, because in the solution electron is there, EnH3 whole y. Then this, due to this electron, solution is conducting. The blue color of the solution is due to the ammoniated electron. You have seen the complex that with the ammonia electron is associated, EnH3 whole y. The blue color of the solution is due to ammoniated electron which absorb energy. Here it is important, which absorb energy in the visual region of light, and thus imparts blue color to the solution. Blue color solution due to the electron, because it absorbs you can say energy in the visual region of light, and thus imparts blue color of the solution. The solutions are paramagnetic. This question is also asked. The solutions are paramagnetic and on standing slowly liberate hydrogen, resulting in the formation of amide. Means metal ion plus electron plus ammonia. Okay, metal ion plus electron plus ammonia, liquid ammonia L. It gives MnH3 2 amide, metal amide, MnH3 2 plus half H2, means hydrogen gas it is liberating. There here M plus AM we are writing, AM means ammonia, small am means shortcut ammonia. Then M plus means it is of ammonia plus electron plus ammonia liquid. Okay, ammonium here, ammonia you have written ionic form, ammonia plus electron plus liquid ammonia. It forms a metal amide, means MnH2 plus half H2. Okay. Then in concentrated solution, the blue color change to brown color. If you will make the solution concentrated, or you can say if solution is concentrated solution, in concentrated solution, the blue color change to brown color and becomes diamagnetic. This is another question. Another question is asked, that in concentrated solution, what will be the color and what will be the magnetic property? Then so many students, just by seeing the electron, they will quickly take decision that okay, solution will be that is the blue solution is due to the presence of electron. But they will not read that this is question is asking in concentrated solution. In concentrated solution is concentrated, that time color will change. Blue color change to bronze color and becomes a diamagnetic. Hence you should be careful. Okay, if it is concentrated, if dilute, then okay, it will give blue, but it's concentrated, then it will give this bronze color and it becomes diamagnetic. Now just to come to the usage, application. Sodium, these alkali metals have many uses. Then I am telling you one by one. Lithium metal is used to make useful alloys. For example, with lead, it makes white metal. Lithium metal, it will with lead, it can say it will make white metal. It is used. Okay, lithium metal is used to make useful alloys. For example, with lead to make white metal. Okay, white metal bearing, you can tell, white metal bearing for motor engine. And with aluminium to make aircraft parts, and with magnesium to make armor plates. Armor means it will protect the, you can say, body, armor parts. Then here, this I told about the lithium metal. Lithium metal is used to make useful alloys. Examples: first, with lead, it makes white metal bearing for motor engine. Second, with aluminium to make aircraft parts. And third, with magnesium to make armor plates. It is used in thermonuclear reaction. Lithium is also used in thermonuclear reaction. Lithium is also used to make electrochemical cells. Lithium battery, you might be knowing, lithium battery. Then lithium is also used to make electrochemical cell. Now come to the sodium. Sodium is used to make a sodium lead alloy. Needed to make lead ethyl, tetraethyl lead. Tetraethyl lead with petrol, this is used. Okay, tetraethyl you are using the word not TEL, tel. With petrol you are putting the tel. Actually this is the TEL, tel. Then tetraethyl lead. Then this sodium lead Ly needed to make tetraethyl lead and tetramethyl lead. Okay, sodium is used directly. Lead is not utilized. Sodium is used to make sodium lead Ly needed to make tetraethyl lead or tetramethyl lead. These organolead compounds were earlier used as anti-knock additives to petrol. Now substitute has come, but in this is also nowadays somewhere it is used, but earlier this is actually organolead compounds. These were earlier used as a anti-knock additive to petrol. Actually, if they were adding that in motorcycle, when you are starting, that it will make a sound. It will make too much sound. Then to reduce that sound, it used to be added additive as a additive substance, anti-knock additive. But nowadays vehicles are lead-free petrol. Vehicles use lead-free petrol. Liquid sodium metal. Now come to the liquid sodium. Liquid sodium metal is used as a coolant. Very, very important. Liquid sodium metal is used as a coolant in fast breeder nuclear reactor. In nuclear reactor, this is used. Okay. Now come to the potassium. Potassium, its vital role is in a biological system, means in our body. Okay. Potassium chloride is used as fertilizer. Actually it is in biological system, means in our body also 70 kg, person weight is 70 kg, then 170 gram of potassium is present in our body. If any person weight is 70 kg, then 170 gram potassium is present in his body. Sodium is also present, but there is a less, around 70 gram only, but it is a more. And also potassium chloride is used as a fertilizer. Okay. Potassium hydroxide, KOH, potassium hydroxide is used in the manufacture of soft soap. Bathing soap. We take bath, that soap is called soft soap. And cleaning purpose, cloth cleaning, that is called hard soap. There NOH is used. And here in bathing soap, potassium is used. Fatty acid of actually both soaps are what? One is the, you can say, sodium salt of fatty acid. Sodium salt of fatty acid. That is the for cleaning purpose, washing soap, WASH, washing soap. And this potassium, you can say, salt of fatty acid, that is for bathing soap. Then here in bathing soap, it is potassium is used. Okay. It is also used as an excellent absorbent of carbon dioxide. It will absorb the carbon dioxide also. Hence it is used as an excellent absorbent of carbon dioxide. Cesium, come to the cesium. Cesium is used in devising the photoelectric cell. Photoelectric cell, you require electrodes. There cesium is required. Okay, and francium, you know, that is a radioactive element. Then now I have told this about the chemical properties of alkali metals. Now, actually, next class I will discuss general characteristics of the compounds of the alkali metal. Next class. Now I am stopping only here. Thank you.